All right, here we go. Hey, we're live. We're live. We're live. Really? Garrison?
Are we gonna be able to listen to this?
Yeah, yeah. All right. So first question. What's our first? So this is what I need you guys to do. I need you to make sure that we're acting appropriately, that we're making appropriate, not inappropriate, but appropriate comments. Act normally, but just show some restraint. Especially like this table right here. What questions do you guys have on this one? I want to answer specific questions. Yeah, go.
A rocket weighs 2.
All right. So you want me to go over the first one?
Oh yeah.
Okay. Here we go. Oh yeah. All right. So we have a. I need to draw a rocket.
Wow, that's good.
You like that right there? All right, so we draw a rocket, and when the rocket is at liftoff, what we have to do is we have to figure out the forces involved. So when it's, think of the space shuttle propelling into the Earth's atmosphere and eventually into space. How does it work? What are the forces that are acting on the engine, or excuse me, on the spacecraft? Isaac. Force of gravity. So we're going to write that. And this is probably really a small thing that you have to, make it a small little adaptation. If you write gravity as mg, it's going to help you out in this problem, more so than normal. The next one, we have gravity pulling it down. What's overcoming gravity? Someone help me out. Greg, go. Yeah, the force of the rocket, the force of the propellant. So we have the force of the rocket. And we're go. No. All right, we're gonna call it the force from the engine. All right. So. Next step. So first one is, what's the net force acting on the rocket? So what do we got to do? We have two forces, opposing directions. What do we got to do? Rachel, go.
Subtract.
Subtract, thank you. So we're going to say that the net force is equal to we see that right there? So the force of the engine is 25. There we go. What's the weight, by the way? What's that? Yeah, it's pretty big. All right. So what's 25 minus 2? 23. So therefore, since they're the same exponents, we can just subtract. Net force. Done. We good? Next question is, it says, calculate the mass of the rocket. Now, the tricky part is, if you do this out of order, you have to be careful. You can do it. You can do it one of two ways. What way do we want to do it? What do you think? How do we want to solve it? How did you guys find the mass? Okay, so you divided by gravity. What did you divide by gravity? What's that? I couldn't hear. This one right here? Good. Good. So this is what she did. She realized that mg is equal to this. So she said, okay, well, So if I divide 2 times 10 to the 7th by 10, what's my mass? What's 2 times 10 to the 7th divided by 10? 2 times 10 to the... Yeah, there we go. All right, units. Make sure you guys keep units up. They're kilograms. So there's our mass. So that was the right way of looking at it. The next thing is finding out your acceleration. So it goes back to F net. What does F net equal to? What does F net equals, Alex?
Mass times acceleration.
All right. So do we know what F net is? Yes. Do we know what mass is? Yes. So we just solve for A. What do we find out A to be? 113 units? Yeah, meters per second per second. Good. So we're going to say this, and we'll go from here.
Wait, on the test, are we supposed to use 9.8 or 10?
10 or 9, it doesn't matter. 10, it doesn't matter. I will go through the test tonight, and I'll make sure that the numbers that I will make sure that if say number 4 used 10, I'll say number 4 used 10, and I'll just have like a list for you guys.
Oh, okay.
You know what I'm saying?
Oh, okay.
Because sometimes the questions are like 10 and some are 9.8. And it's
So that way we won't have to go through and like guess the load.
Yeah.
Tell us which one to use.
Yep.
That was my question.
Okay. Cool. We good?
Yes.
All right. Next question. What is it? Go.
Number 3.
Number 3. Number 3 says, talk about a horizontal force of 50 newtons to slide 20 kilogram table across a floor at a constant velocity. What is the magnitude of the frictional force acting on the object? So here we go. First thing is draw a picture. Okay? What's the mass of it?
20.
20 kilograms, good. And what does our free body diagram look like? What's our free body diagram look like? What's that mean? 50 Newton force, good. Acting to the right, I guess. All right, here's the key word, constant velocity. Or I can say constant speed. So if something is moving at constant velocity or speed, what's the acceleration?
0.
Okay, good. That's the first thing. If the acceleration is 0, what's the net force equal to? 0, good. And if I have 50 newtons acting in one direction, what's the magnitude of the vector that opposes it? 50 newtons. Done. Questions? We good?
Are we doing number 2?
Do number 2. Here we go. A force of 100 newtons accelerates a 30 kilogram block at 5 meters per second each second along a horizontal surface. What is the frictional force acting on the object? What type of friction is it? And what's the net force acting on the object? I got good news. Terrible question. We're going to go ahead and throw that one out. All right, that's it.